When given a one-to-one function f at x, we can find the inverse by using the following steps. The main idea for finding the inverse is that we're going to switch the x and the y variables in the equation. But when we have something that's written in functional notation, the first thing that we're going to need to do is to replace the f at x in the equation with y. Once we have our y variable back, then we can switch all the x and y values. And then in that inverse relationship, we'll solve for y and then call the resulting function the inverse. So let's look at a quick example. The first thing that we want to do is to replace f at x in the function with y. The idea is that we're going to switch the x's and the y's, so in order to do that, we need that y variable. So now we'll switch the x and the y's, which means that everywhere I see a y, I'm going to put an x, and everywhere I see an x, we're going to put a y. So essentially, once we've switched the x and the y, this is the inverse relationship. But because the original function was written in functional notation, we want to now solve for y so that we can write the inverse relationship also using functional notation. So to solve for y, we're going to add 4 to both sides. We'll end up with 3y is equal to x plus 4. Continuing to solve for y, we'll divide both sides by 3, and we'll get y is equal to, let's call this 1/3 x plus 4/3. Now that we've solved for y, the last thing that we want to do is that we want to return to the functional notation. We're going to replace that y variable, but this time we're going to replace it with f inverse of x, because this equation is the inverse relationship, and so we're going to use f inverse for the functional notation. So this is our inverse function. Now the last thing that we want to do is what was indicated in the directions. We need to verify that our answer is correct, verify that these two are truly inverses of each other, and we do that by composing the original function with the inverse function that we found, and that composition should simplify down to being just x. So here I've recopied the original as well as the inverse function, and now we're going to compose these two in either direction. We could say f of f inverse or f inverse of f. Here we have f on the outside, f inverse on the inside, and so we'll copy down our f function, leaving a hole for the independent variable, and then plug f inverse into that independent variable spot. And now we'll simplify, but first we'll copy-paste the left-hand side, then we'll distribute the 3 into this parenthesis to get 3 times 1/3 x is just x, 3 times 4/3 is going to be plus 4, and then we still have the minus 4 from the end here. And we can see that after we cancel the 4's, f composed with f inverse does turn out to be positive x, which is what we needed to verify that these two functions are inverses of each other. So we did complete that last requirement.